Hello viewers, this is Wagada Ronald taking you through today's tutorial on application to differentiation 1. And today's lesson shall talk about a shorter approach of sketching standard curves. So we shall begin with standard curves of quadratic functions. Such curves have a special name, parabola, and such curves are in the form y equal to ax squared plus bx plus c, or x equal to ay squared plus by plus c, where a, b, and c are constants. In other words, they can be integers or fractions, and a is not equal to 0. So b and c can either be 0 or not, but a must never be equal to 0. Now, after knowing that, we have to talk about two terms which we will be using most frequently. One of the terms is the axis of a curve, and the other one is the vertex of the curve. Now, what is the axis of the curve? See, this is the line of symmetry of the curve, or the line about which the curve is symmetrical, while the vertex is the point where the axis cuts the curve. So we shall start with a case whereby b and c are equal to 0. So in this case we remain with y equal to plus or minus ax squared, or x equal to plus or minus ay squared. And we shall consider a case whereby this coefficient is positive. So we shall consider y equal to ax squared. So the first step is to get the axis. Remember, the axis is the point where the curve is symmetrical, is the line where about which the curve is symmetrical. Therefore, it is got by equating the whole of this term with a squared part equal to 0. So when I equate equal to 0, I'll come up with x equal to 0. Now this will be my line about which my curve will be symmetrical. Next will be the vertex. Vertex is the point where the axis cuts the curve. So when x is equal to 0, we shall come up with our y equal to 0. So come and put it 0 here. You remain with y equal to 0, which is this. Therefore 0, 0 is our vertex, and also 0, 0 is our intercept. Now the next step is to sketch the curve. So this is how the shape of the curve will be. If what matters is the coefficient on this squared term. So if this coefficient is positive, it will be in this form, and if it is negative, it will be in that form. The next thing that matters is the vertex. I think you can see our vertex in this case was 0, 0, so come and put 0, 0 here. This is where the curve will turn. In other words, will be the turning point of that curve, so that this part is similar to this, and in that case this will be our axis or line of symmetry. So that is how they sketch curves in the form y equal to plus or minus ax squared. So that a can be any value. It can be y equal to 2x squared, y equal to 3x squared, and this one can be y equal to negative 5 squared, y is equal to negative 10 squared, 10x squared, etc. Similarly, on the other hand, curves in the form x equal to plus or minus ay squared can be drawn in this form. So this is when the coefficient is positive on y squared, and this is when the coefficient on y squared is negative. So next is the curves in the form where b is equal to 0. So in this case we shall have y equal to plus or minus ax squared plus c, or x equal to plus or minus ay squared plus c. Now let us use a case with a positive coefficient, and it will be y equal to ax squared plus c. Still, the first step is to get the axis, and the axis got by equating this squared term to 0. So when I equate to 0, I come up with x equal to 0. So in this case, x equal to 0 will be my axis, and the vertex, remember we say the vertex is the point where the axis cuts the curve. So when x equal to 0, you have to look for the corresponding value of y. So when you put 0 here, you remain with y equal to c. Therefore, the coordinates of the vertex is 0, c. And similarly, also the coordinates of the intercept will be 0, C. And last step is to sketch the curve. So this will be the shape of the curve. Remember, what matters first is the sign on this coefficient of x squared. So if the sign is positive, it will be in this shape like we saw in the previous case, and if the sign is negative, it will be in this shape. So what has shifted is the vertex, position of the vertex. Previously the position was 0, 0, and therefore the vertex was at the origin, but now the vertex is 0, C, so come 0x and cy. So now this is our vertex. So what matters are the signs on the x squared and also the vertex. Now similarly, curves in this form can be drawn, sketched as here. Still, what matters is the sign on the y squared. So when the sign is positive, this curve will be in this shape, and when the sign is negative, the curve will be in this shape. And also, after knowing the sign on this coefficient of y squared, next is to look for the vertex. So the vertex in this case, it is C0, which is here. Another case will be the case where C is 0 but A and B are not 0. So in that case, we remain with y equal to plus or minus ax squared plus bx, or x equal to plus or minus ay squared plus by. So let's use the case of positive coefficients. So in this case, we shall have y equal to positive ax squared plus bx. So in this case, the first thing to do is to complete squares. So how do we complete squares? If I have this, the first thing to do is to make this coefficient equal to 1. How? By dividing throughout by a. When I divide throughout by a, I'll get y over a equal to x squared plus b over a x. Now next is to complete squares. How do we complete squares? Look at this coefficient of x. Half of this coefficient is what we put here. So we end up with x plus b over 2a, everything squared. Then minus, now you come back to this coefficient and square it to get what we put here. So in short, that is the brief way of completing squares. Next will be simplifying. So when I simplify, bring this one this side, I'll come up with y equal to a in brackets x plus b over 2a squared minus b squared over 4a. So in that case, I've completed squares, and the next step is to get the axis. For the axis, we have to equate the squared term to 0. So we equate the whole of this to 0. We shall come up with this step, and in the end, we shall get x equal to negative b over 2a. So this will be the line of axis where about which the curve is symmetrical. Now the vertex of the corresponding is a point where this axis cuts the curve. So when x is equal to negative b over 2a, our value of y will be equal to negative b squared over 4a. And therefore the coordinate of the vertex is negative b over 2a and negative b squared over 4a. Now next is to get the intercept. Intercept, when x is 0, y will be 0. So when you put 0 here and 0 here, you'll come up with your y as 0. On the other hand, when y is 0, it means the whole of this is equated to 0. And when you factorize out, you come up with x in brackets ax plus b. Therefore, we have two values of x, where one x is equal to 0, another one is equal to negative b over a. Therefore, the intercepts will be 0, 0 and negative b over a 0. So we have got the intercepts, we have got the axis, and we have got the vertex. Next is to sketch the curve. So this will be our sketch. I think you can realize that because this coefficient is positive, the curve will be in this shape, and this one is negative, the curve will be in this shape. Next is to look for the vertex. The vertex was negative b over 2a and negative b squared over 4a. So this is our vertex. Then also you look for the axis. The axis was x equal to negative b over 2a, which is this. I think you can see that this one is the line of symmetry of this curve and this curve. So look for the sign here and also look for the vertex. So that is how the curves can be sketched briefly. Now similarly, the other kind of curves of x equal to positive ay squared plus by and negative ay squared plus by can be drawn in this way. So in this case, when this quotient of y on y squared is positive, it will be in this shape, and when the quotient of y squared is negative, it will be in that shape. Now the vertex will be this, x equal to negative b squared over 4a and y equal to negative b over 2a. So look for the vertex and also look for the sign on y squared, then you'll be able to sketch it easily. Next, now we shall go to standard curves of cubic functions. So case 1, we shall start with cubic functions in the form y equal to plus or minus in brackets a, x plus a, x plus b, and x minus c. So in this case, this is cubic because when you expand this, you come up with the highest power as x cubed. Therefore, the first thing to do is to remember that for cubic curves, when this is positive and a, b, and c are constants, and also this, so always find out the sign on x cubed. So in this case, when I expand this, I'll realize that my x cubed is positive. For example, this is positive x, and positive x. So positive x times positive x times positive x, I'll come up with positive x cubed. So in this case, the term on x cubed is positive. That is the first step to do. Next is to get the intercepts. The intercepts are got by equating this y equal to 0. Now when y is equal to 0, we shall come up with this equal to 0, or this is equal to 0, or this equal to 0. When this is equal to 0, x will be equal to negative a, and that's where this intercept is coming from. When this is equal to 0, x will be equal to negative b, and that's where this intercept is coming from. When this is equal to 0, x will be positive c, and that is where this intercept is coming from. So after getting the intercepts and the sign on x cubed, then we shall now draw the curve. So when the sign on x cubed is positive, the curve will be in that shape. So these will be the intercepts: one intercept, second intercept, and third intercept in ascending order. Now when it is positive, it will be in this shape. What if it was negative? How would it be? So if it is negative, then the shape will be in that case. I think I realize that there is a change. This one was in this form, and now this one is in this form. In other words, as x reduces, y increases, and as x increases, y reduces. For this case, as x reduces, y also reduces, and as x increases, y also increases. So that is the difference between when the sign on x cubed is positive and when the sign on x cubed is negative. So case 2 shall look at cubic curves in the form y equal to plus or minus x plus b and x minus c. So I think we realize that in this case there is a repeated factor. X minus c is repeated. What happens when there's a repeated factor? It implies that the intercept at that point with a repeated factor is a turning point, and that turning point is a minimum point. So when you get the intercept for this by equating this to 0, we shall be able to get a minimum point to that curve. So when x minus c squared is equal to 0, x will be equal to c, and when x is equal to c, y is equal to 0. What does that mean? It means that c0 is a minimum point to this cubic curve, and therefore the shape will be in this form. I think I realize that there are two intercepts, but the intercept where the factor was repeated is a turning point, and in this case it is a minimum point because the term on x cubed is positive. So when the term on x cubed is positive, that intercept with the repeated factor is a minimum point. On the other hand, if the term on x cubed is negative, then that coordinate, that intercept with a repeated factor is a maximum point, as you can see here. So in this case it is a minimum point, in this case it is the maximum point. Therefore the curve in this shape will follow that path, and for this kind of curve it will follow this path. So always remember, the first thing to do is to look for the sign on x cubed. Next we shall go to curves in the form plus or minus ax minus b cubed plus c. As you can see that here it only has one intercept, and when it has only one intercept, what happens? So in that case, look for the sign. If the sign is positive, then the turning point will be a point of inflection. Whether it is positive or negative, it will be a point of inflection, but the shape matters. So when the sign on x cubed is positive, then our point of inflection will be in this form. So we equate the whole of this to 0 to get x equal to b, and when x is equal to b, y will be equal to c. Therefore this is our point of inflection, but it should be in that shape. So start with positive, and also after that point will be positive. That is the point of inflection for curves where x cubed is positive. This is the curve we saw previously, but when this x cubed is negative, for example, if the curve is in this form, I think we realize that x cubed will be a negative. So this is x cubed, but there's this minus here, so it will end up being a negative. What happens? It means that this intercept is also a point of inflection, but it changes shape. It starts with a negative gradient and ends with a negative gradient. For this case, where x cubed was positive, it started with a positive gradient and also ended with a positive gradient. So this will be the difference between the two kinds of curves. So always, when you're dealing with cubic functions, first look for the sign on x cubed. Now we shall go to standard asymptotic curves. So here we have a new term, an asymptote. So an asymptote is a line where the curve never touches or crosses but tends towards it. So the curve must never cross this line, and the curve must never touch that line, but it can tend towards this line. So that line is known as an asymptote. And the value of x for which y is undefined gives the vertical asymptote, while the value of y for which x is undefined gives the horizontal asymptote. So that's how they get the asymptotes. We can get the vertical asymptote or horizontal asymptote. So now we shall go to case 1 of asymptotic curves, which are in the form xy equal to plus or minus c. Now in this case, c is a constant. It can be 2, it can be 3, it can be 5, it can be 10, it can be any value. So curves in this form can be drawn as we shall see in the following procedure. So first is to rearrange and make y the subject to come up with plus or minus c over x. Now when y is equal to 0, I think we realize that x will also be undefined. Therefore this will be an asymptote. The curve never touches this line. Similarly, when x is equal to 0, y will be undefined, and therefore the curve never touches the line x equal to 0. What does that mean? It means that the line y equal to 0 and x equal to 0 are the asymptotes to this curve. And now we shall sketch. For sketching, we shall start with the ones with a positive constant. So for x, y equal to positive c, when x, for positive values of x, for example, when I put positive 1 here, I'll come up with y equal to c, which is positive. And that is why for positive values of x, the curve is above the horizontal asymptote. This is our horizontal asymptote. For negative values of x, when I put negative 1 here, I'll come up with y equal to negative c. Therefore, for negative values of x, the curve is below the horizontal asymptote. So that is how they sketch curves for positive constants. So xy equal to positive c will be this and this. I think we realize that the curve does not touch this vertical asymptote and also does not touch this horizontal asymptote. On the other hand, for negative constants, for example, xy equal to negative c, for when the values of x are negative, for example, if I put -1 here, I'll come up with my y equal to c, meaning y is positive. Therefore, for negative values of x, the curve will be above the horizontal asymptote. On the other hand, for positive values of x, when I put a positive value here, I'll get a negative value of y, implying that the curve will be below the horizontal asymptote. So in that case, a curve of xy equal to negative c will be this and this. I think I realize that it does not touch this horizontal vertical asymptote, and also it does not touch this horizontal asymptote. So similarly, they can give you a curve whereby there are some value constants here, can be y minus 2, x minus 3. So in that case, it will be drawn as we shall see below. So the first thing to do is to look for the asymptotes. How do we get the asymptotes? Equate the whole of this to 0 and get the corresponding value. When you equate to 0, for example, when y minus a is equal to 0, it implies that x will be undefined. Therefore, this one can give an asymptote, and also when you equate the whole of this to 0, y will be undefined, meaning that this can also give an asymptote. Therefore, when y minus a is equal to 0, y is equal to a, and when x minus b is equal to 0, x will be equal to b, meaning these are the asymptotes to the curve. In other words, the curve never touches the line y equal to a, and also never touches the line x equal to b. So the next step is to sketch the curve. So the curve will be in that form. The first thing to do is to draw the asymptotes. So when this will be the vertical asymptote, x equal to a, and this will be the horizontal asymptote, y equal to b. After drawing those asymptotes, you remember that for this part, it will be above the horizontal asymptote, and this part will be below the horizontal asymptote, like we saw in the previous case. That is for y minus b a, x minus b equal to positive c. But for y minus a, x minus b equal to negative c, this part will be above the horizontal asymptote, and this part will be below the horizontal asymptote. So those will be the shape of the two curves given. Case 2, we shall go to asymptotic curves in the form x squared y equal to plus or minus c. So still we have to rearrange and get the asymptotes. So in this case, when the whole of this is equal to 0, x is undefined, and also when the whole of this is equal to 0, y is undefined. Therefore, it means that the asymptotes are y equal to 0 and x equal to 0. In other words, the curve never touches this point and the line, and also never touches this line. So it will be in this shape. For positive constant, the curve will be above the horizontal asymptote. Always, for example, if I put here positive 1, I'll get the positive value of y, and also if I put -1 here, -1 times -1 will give me positive, so in the end I'll get a positive value of y. So whether the values of x are negative or positive, the curve will be above the x-axis. But for this case, on the other hand, if this constant is negative, it means that whether the values of x are positive or negative, the values of y will always be negative. Therefore, that is why it is below the x-axis, or below the horizontal asymptote. Now similarly, they can also put constants here, and it becomes x minus a squared multiplied by y minus b equal to plus or minus c. So the first thing to do is to get the asymptotes. So when y minus b is equal to 0, x is undefined, and when x minus a is equal to 0, y is undefined. What does that mean? It means that the asymptotes are got by from here. When y minus b is equal to 0, y is equal to b, and when x minus a is equal to 0, x is equal to a. And therefore, for you to sketch the curve, the first thing to do is to locate the asymptotes. So this will be x minus a, and this is y minus b. Then we say that for when the c is positive, it means that the curve will always above the horizontal asymptote, so it will be in this shape. On the other hand, when c is negative, it implies that the curve will be below the horizontal asymptote. It will be in that shape. Now shall I go to case 3 of asymptotic curves, where now it is y which is squared. So we get y squared x equal to plus or minus c. So in that case, we have to also first get the intercepts. So y equal to 0, x is undefined. When x is equal to 0, y is undefined. And in that case, the asymptotes will be y equal to 0 and x minus 0. And therefore, the curve will be in this shape. Now here I realize that whether the value of y is positive or negative, x will be positive for positive constant here and negative for negative constant here. Therefore, when the constant is positive, y, the curve will be this and that. And when the constant is negative, the curve will be this and that. So that is how they sketch such curves. So similarly, they can give you a curve in this form: y minus a squared x minus b equal to plus or minus c. So the procedure remains the same. You have to first look for the asymptotes. So in this case, when x minus b is equal to 0, y is undefined, meaning that this can give us an asymptote. And also when y minus a squared equal to 0, x is undefined, meaning this can give us an asymptote. Now when x minus b is equal to 0, x will be equal to a, and when this whole of this is equal to 0, y will be equal to, x will be equal to b and y will be equal to a, meaning that x equal to b and y equal to a are the asymptotes. Therefore, the first thing to do is to locate the asymptotes x equal to b and y equal to a. That you remember, like we saw previously, that when c is positive, the curve will be this and that. And when c is negative, the curve will be this and that. So those are the two shapes of the two curves given. So it's now your turn to try the following problems. So that has been problem 1, part A, then part B. Compare answer with that. So that is problem 2, part A, then part B is that. So you try it out and compare your answer with this. So that has been our lesson for today. Thank you for watching, and please subscribe to my channel, Rowa e-learning platform. Thank you.